Hello, this is Mr. Frank, and today we are going to be looking at question 18 from the June 2022 Algebra Regents, and saying how we can solve this using the DESMOS graphing calculator. Number 18, Mrs. Rosano asked her students to explain why 3 negative 4 is a solution to 2y plus 3x equals 1. 3 student responses are given below. Andrea, when the equation is graphed on a calculator, the point can be found within its table. Bill, substituting x equals 3 and y equals negative 4 into the equation makes it true. Christine, the graph of the line passes through the point 3, negative 4. This is one of those questions where they're asking which of those students is correct. Is it Andrea and Bill? Is it Bill and Christine? Is it Andrea and Christine? Or all three, Andrea, Bill, and Christine? All right, well, that means we got to try to do each one. Well, the first thing that I like to do when I see any equation, and something that's new with the DESMOS calculator, is that we could just put that in how it's given, 2y plus 3x equals 1, into the calculator. So let's go over to our DESMOS calculator. I'm going to click in on the upper left screen where we enter our functions and our equations, and I'm going to put in 2y plus 3x equals 1. Now, we can see that the line does appear, and I can come over here, I can see what my y-intercept is. Click on that, there's my y-intercept. They even give us our x-intercept. However, one thing that we will not be able to get with the way we entered this equation is if I go up to my wheel where I usually find my table of values, nothing appears. I'm like, uh-oh, what am I going to do? Well, this is one of those instances that if we want to see the table of values for this, we are going to have to be able to solve for y and put this into, say, slope-intercept form. All right, so let's do that. It's not so hard. So I'm just going to use this as my scrap paper. And if I want to solve for y here, the first thing I'm going to do is take this positive 3x, and I'm going to bring it to the other side of the equation. And when I pass any expression to the other side of the equation, it's going to change signs. So this positive 3x is going to become negative 3x. So I'm going to rewrite that right here. So I'm going to have 2y is equal to negative 3x. And that 1 stays there. And since there's no sign there, it means it's positive. So I'm going to keep it positive 1. But then to solve for y, I still need to get rid of this 2. The 2 is multiplying. So I'm going to divide away this 2, which means I have to divide both of these things on the other side by 2. Cancels out, and then the final answer here is going to be y is equal to negative 3 over 2x plus 1/2. Okay, now that we solved for y, we can go back to our graphing calculator. And I'm going to hit right underneath that to number 2. I'm going to click in there, and I'm going to enter that in. Y is equal to negative 3 divided by 2. Now, you see how it's kind of flashing next to my denominator of 2? Before I put the x in, I'm going to hit the right key and move 1 to the right. So I'm right next to it now, and then I'm going to put my x in. And to finish off, I'm going to go plus 1/2. So I'm going to go plus. Just a little note, when I use the division, the /, it automatically changes it to a fraction for me, which is a really nice part of DESMOS. Plus 1/2. And enter. Okay, so you could see that a purple line appeared exactly on top of the other line. That's a really good clue that we solve for y correctly. Look, I can go to the left of this line that I just put in, right where I see the purple line here, and if I click that, it disappears. and I can see the original red line there. And if I go back, it's directly on top of it. That's a good sign that I did this correctly in solving for y, and now I can continue with the problem. Now, if I go back to the problem, Andrea said when the equation is graphed on a calculator, the point can be found within its table. All right, so let's make a table. So we're going to go back to the calculator, and I have number 2 clicked. I'm going to go up to my wheel, and I'm going to click it, and a little table, convert to a table. That's what I want to do. And there's my table. However, we're checking the point 3, -4. Well, the value of x there is my 3, and when I look at my table here, it only goes up to 2. Well, no problem. We already learned in a previous lesson that we can just click right underneath that 2 and type in a 3. And there we have it. Our table of values goes up to 3, and the value of y is -4. So now I'm going to go back to my problem and say, well, Andrea, she was correct. So I'm going to just put a little C next to hers right there. All right, let's see what Bill was saying. Substituting x equals 3 and y equals -4 into the equation makes it true. 3, -4. All right, well, it's -4 for the y and 3 for my x. So I'm going to go back to the calculator. And I'm going to look at this previous equation right up there. I'm going to go down to number 3. And I'm going to just type exactly what it says. But when I get to the letters, I'm going to use parentheses. And I'm going to substitute values. So 2, open parentheses. The y value is -4. So I'll put a -4. Close my parentheses. Plus 3, open parentheses, and the value of x was 3. Close it and hit enter. And sure enough, right here on the side, it says is equal to 1. So I entered the values for that point, my x for 3, my y -4, and it was equal to 1, giving me a true statement. That means that when I go back here, substituting those numbers in made it true. It absolutely did. So I'm going to put a C. Bill was also correct. Now I can see down here with my answers, I'm going to be a good test taker, right? It says, I already know that Angie and Bill are correct. So I know that this is a possibility. And well, you know what? I can't actually eliminate any until I do Christine. So let's do Christine. Christine says the graph of the line passes through the point 3, -4. Let's look at the line here. Well, if I go to the line right here, I could see the line. And even if I look at the line here without the purple, even if I look at the line just with the original 2y plus 3x equals 1, if I go to the line and I just click on it and move up and down the line, it's actually telling me all of the infinite number of points that are on that line. But this wanted me to evaluate 3, -4. So I'm going to inch this up till I get to 3. And look, I actually am able to stop. It helps me do it. When x equals 3, right there, y equals -4. So it is on the line. And just to give you another cool little thing that we can do here with this, is that we can actually go and to this plus sign here. I'm going to add a table. And on this table, I can put any point I want. So I'm going to put a 3 for my x, and I'm going to put a -4 for my y. And look, it put that point on my graph, and it ended up right on top of that line, reinforcing the idea that indeed Christine is also correct. So I'm going to put a C next to her name as well. Oh, she got a big C. So Andrea, Bill, and Christine, all 3 of them were correct in explaining why 3, -4 is a part of the solution to 2y plus 3x equals 1. So which students are correct? Andrea, Bill, and Christine. So number 4 would be the correct answer. Hope that was helpful. Don't forget to subscribe to Mr. Frank's YouTube channel.